Right, I'm now going to move on and talk a little bit about points rather than just vectors. So far I've talked about vectors, which have a magnitude and a direction, so they have an end point and a start point. Whereas if we just want to be able to define a particular point in space, we need to have a reference point or an origin. So imagine that we have a set of axes like we had previously. So this is going to be x, y, and z, which we think about as being having the unit vectors of I, j, and k vectors, put a line under them. And I can have any point at all in that space, so I'll call that A. If I call the 0, 0, 0 point, the origin, then I can get from the origin to A by going a certain distance along the I direction, along the x-axis. I come along here, I go a bit along the y-axis, and I go a bit up the z-axis till I get to the point. And we've talked about A1, A2, and A3. We define the point in space, so the point A, we just talk about what's called an ordered triple. So we go A1, A2, A3, okay? So that's for a point. So it's not a vector, it's actually representing the point in space. So this point in space sits at the point A1, A2, A3. Very similar to defining points on a Cartesian plane, x and y. You talk about the point 5, 1, which means 5 along the x-axis and 1 up the y-axis. Here we just have a third thing. So we have a third coordinate, which is effectively in the z-axis. Okay, so this is an ordered triple for a point in space, not to be confused with a vector. It has three components, as a vector does, and they are related to the I, j, and k, but this is an actual point. It's not a vector, it doesn't have a magnitude, it just has a point. Okay, so a point in space is represented by an ordered